picture of myself. All right, and then do you see this pie shirt? You see this? I want to tell the story. I'll tell it all day long. It's got my name on the back, and it's got, what is the numbers? 358. So back, this shirt is probably from 2000, 2001, somewhere around there. And we actually had on Pi Day, and that's why I'm wearing this again, Pi Week, I guess. On Pi Day, we actually had in the math hallway a whole bunch of activities, and actually some things that involved guessing. I remember one of the things they had, I think, marbles in some sort of multi-dimensional, a three-dimensional object, like a cylinder with a pyramid kind of thing on top of it. So they were supposed to guess how many marbles were in this shape. All right, and you could use volume, compare the volume of the two objects and then the volume of what a ball was. That's who actually won. It was mathematicians, kids that were able to, guess to a very precise amount how many marbles would fit in this object. But then at the end of the day, every math teacher got this shirt, and I'm actually 3 digits of pi somewhere. Our I think it was Mr. Samide. I hope I have this right. He was one of our most respected teachers at Wheaton North. He was 3.14. And then our department chair was the next. He was very respected too, and I might have him switched. It was one way or the other that we had the two top dogs of our department be the first two sets of the numbers. Then all the rest of our teachers had 3 digits, and then at the end of the day, students had to put us in the correct order as teachers. And they knew this was going to happen. So the people that studied it and so on and so forth. Then after all of that, a teacher got elected to get a pie in the face. And it was by a vote. And then guess who won that vote, I guess, which would be winning, I guess. It was me. And I got a pie in the face at the end. And it was the whole school was in this assembly. You ever hear what an assembly is? We don't do them anymore. For some reason, they're illegal. All right. But it was one of the greatest things. So I always, when I wear the shirt, I tell that story as a reminder, just back in those days when we had those fun things. And my wife has this shirt. That's actually where I met her. And then I still have many of those friends. They still keep this shirt. So anyway, back to this. We had a student already mention this, and someone got it last hour too. What is the area of a segment? Well, first of all, that is an area of a segment, just that little part right there. And it's area of the whole sector minus the area of the triangle. All right, and then and I'll just put that for symbolism. That's it. So all I have to remember is how do I get an area of a triangle in order to answer this question? And I already know how to do area of sector. I will do this first one and not be lazy. Sometimes you do have to read a question and do the drawing. But number 11 ends up being just like number 12. So I'm not going to waste our time with number 12. So the radius of a circle C is 12 feet and ACB is 90 degrees. Find the area of the segment that incorporates that, that particular. Probably should have a little better wording there. Leave your answer in exact and to the nearest hundredth. Okay. Another thing about Mr. Samide, he used to be able to draw a circle almost to perfection every single time on a board. He'd keep his arm like this and go like this, and it would just be nearly perfection. It was actually awesome. All right. So center 12. 12, and that doesn't look like 12, but I'm not Mr. Samide. All right, meaning they don't look like the same one. I tried. All right, and then luckily this is 90 degrees, which makes this first question a little bit easy. All right, and then there's the area that we're trying to find. And then I passed out the new worksheet, right? The new worksheet, the shading didn't show up so much, so I drew those little lines to denote the shading. Now hopefully you can see that, just to make sure you know. All right, so area of sector is easy. So sector minus triangle. That's the idea here. And this first one's Mickey Mouse. And I'll be done, much shorter than last hour. Maybe be able to stamp for you guys. All right, so area of sector is 90. That wasn't the pen that time. I'm writing shaky here. Divided by 360, or we already know 1/4. 1/4 times pi r squared. I'll do r squared times pi. And then minus. Luckily, this is a right triangle. All right, so this is first easy. Because in a right triangle, this is standing straight up and down. So 12 is the height. And then 12 is considered this base. So I can use half base times height, right? All that happened yesterday is I ran out of time. This wasn't necessarily a difficult concept, but there's some questions here that are a little bit like towards the end, we got a really challenging question. I probably have to think about it a little bit more, but 12 squared is 144. 1/4 of 144, I think, is 36, is what we got last hour. And then half of 12 is 6. 6 times 12 is 72. All right. Now, those cannot be combined. Pi is not a variable, but it works like a variable where I just can't subtract those. So that is the exact answer. And this is area, so it is in feet squared. Now, going to my calculator. All right, and I think I already typed this one time, so I'm just going to cheat and be lazy here. And that's all you got to do. When you go to the calculator to get the approximate, I guess I could just go to my previous typings here. That's all you got to do. You just go to your calculator, find the pi button. I guess if you use 3.14 instead of pi, it'd be close enough. But you get 41.10 is actually what that ends up being. Oh, and then the idea of our shirts, like it would just like we thought pi was super. So this is a Superman shirt, super pi. Just looked at myself again. I actually love this shirt. It's actually kind of newer because I only wear it like once a year. What was it, 41.1? And then that's also feet squared. So the idea of exact and rounded or approximate would be the another. Approximate to the nearest hundredth. And it was 0.09 something that moved the 9 to a 1, so that's why it's 10. Now this is why I love this one, because I'm going to actually call out some of you people that did something great. Who's doing that noise? Do you hear that? Anyone hear that, or am I just going crazy? Did you hear that? Just say you heard that. I thought I heard someone go. Are you sure, Caleb, over there you weren't making noises? Anyway, all right, so let's break this down. XYZ, or XZY, wrong. XZY is 60 degrees. Watch what happens. This is awesome, which creates 3 different things I can remind you of. And then what I was saying there when I thought I heard noises is a third formula could be used for a triangle. By the way, why do I know these two are equal? Because those are 3, 2, 1, go. Radii. That's actually the plural of radiuses. Or radius. Don't say radiuses. All right, and then that makes this triangle isosceles, right? But you're wrong. Because since this is isosceles, what do these two angles have to be as a measure? 3, 2, 1, go. Another 60. So why did I trick you and say isosceles is wrong? Because it's actually equilateral. All right, because it's equiangular. So by accident, we find out that we have an equiangular, equilateral triangle here. So it's still going to be, sector minus triangle. But now this opens a whole new world. Anyone know the movie? Anyway, triangle. Which one is that, by the way? Little Mermaid? No. Aladdin. All right. Sector minus triangle. All right. And we got a lot of options now for the triangle. So I'm going to pull that triangle out real quick since I didn't do this. Pull this out. And then I love this. This accidentally, I knew I would be able to do this, but then I get a chance to talk about an old concept now. So how do I find the area of that triangle? Well, I need half base times, what do I need? Height. So this is actually the deriving of our special triangles where we drop this height, this perpendicular in an equilateral triangle. And then what did it do to this angle measure? It made these two what? What are both of these? 30 and 30. And then, oh, by the way, this is 18. So this is 18. But what did it do to this 18? Cut it in half. And then by the Pythagorean theorem, don't do the Pythagorean theorem. Everyone should know what this height is now. 9, 18. What's the 3, 2, 1, go. Not 9. I still haven't heard it loud enough. 9 times the square root of, oh my gosh, I'm getting a whole bunch of different answers. 2, 3, 7, height. Throw a touchdown. 9 root 3, 2, 1, go. 3. 9 root 3. How many people got 9 root 3? Raise your hand. It should have been. All right, should have been everybody. All right, the whole A root 3, 2A thing in a 30, 60, 90 right triangle. All right, our special triangles that we spend so much time on. Okay, so I have that. Or, how many people, let's be honest, looked up that video on that third area formula just for fun called Huron's Formula? Because I know you did, because some of you used it on our last quiz on an area question where I gave SSS as a thing. Anyone look up that video? Did you? No, you didn't. I know somebody did because I saw some people use Huron's Formula on the test. There's a formula when you have all 3 sides. It was 18, by the way, right? Okay, yeah, 18 yards. When you have all 3 sides, there's a formula that you can stick to all 3 sides and then get the whole area there. I have that little video back in that little, I think in February, maybe it was in March, for that. So I'm still gonna mark it. Or we could scrap all of those. This is 18. This is 18. And I was given this angle and pretend I didn't even think about those angles. That's SAS. And I had a formula for finding the area when given SAS. They want to remember what that is? Half side times side. And then what do I do to this angle measure? Which trig function? Someone's got to remember this. Sine. Okay, so I'm going to write this in 3 different ways. But I'm not going to write Huron's formula because you're not responsible for it. But it is a nice extra thing. And I think there are some people in here that actually looked that up. You're just not admitting it. Or maybe don't remember what I'm talking about, but because I saw you use Huron's formula, you know what? Forget it, because you're all looking at me like I'm an alien, which I wish I was, traveling the universe and visiting other planets. But that's beside the point. March 2nd? Another area formula. Booyah, right there. I could have swore that some people looked at that and then used it on the test. All right, so there it is. Huron's formula, but let's move on. So area sector, 60 divided by 360 times pi r squared, 18 squared times pi. And then minus triangle. So minus, since I know 9 root 3 is the height. By the way, what's the base then? Is the base 9 or 18? What's the base? Height times base, 18. It's half base times height, or if I didn't want to even pull that triangle out, or minus half SAS, that is 18 times 18, fumble, times the sine of 60 degrees. Now I'm going to tell you right now, I'm going to be creative tomorrow and make up questions where you are going to have to remember that formula. That's what's good about math. You can kind of remind yourself of previous things. You know, I'm actually going to go for a challenge tomorrow, maybe. Or minus Huron's formula. If you looked at that March 2nd video, and all of them would be the same. By the way, what's the sine of 60? Yes, I should be able to ask that question and somebody be able to get this answer. By the way, sine of 30 is a half. So sine of a 60 is that other ratio that I had a lot. Root 3 over 2. Okay, so look at how this happens. Sine of 60 is root 3 over 2. You know what root 3 over 2 times 18 is? Just take a guess. 9 root 3 times 18 times a half. And then you would get this 9 root 3 somehow in Huron's formula as well. Actually, in that video from March 2nd, I do both Huron's formula and then I do the half AB sine C thing to show you that, see, you get the same answer no matter which way you do this, if my memory serves correctly. Okay, you get the point, I hope. You got to do one or the other, and these are the kind of questions I'm going to make up tomorrow where the angle in between is like 23 degrees. You can't even do that. You're going to have to use this formula, right? And remind yourself of that from the past. Okay, this is the tough one. Ooh. Are you ready? Are you ready for this? Boom, 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 boom. Okay, so the area of the segment is given. Calculate the radius. Okay, and then luckily we're back to 90 degrees. That's radius R and R. Okay, so remember in words, it's sector minus triangle equals area of the segment. We're just not writing the word area. We're shorthanding it. And I couldn't think of it. I'll probably think about it later. It's not important, but we're going to need our calculator on this one. We're going to need to keep this in calculator ready form. So the area of the segment, let me get rid of this so you don't confuse that this is part of this, is what's given. So I get to insert that in. We're going to leave this in exact form. And I'll just leave the feet squared off for a minute. All right. What's the area of the sector? Well, luckily I have 90 there, so it's 90 over 180. I'm sorry, 90 over 360, which we probably should be putting as 1/4, but let's throw it in as is. R squared times pi. This is a tough. We actually did this in regular math too with sophomores, like in 2015. This question, so we should be okay. Just inserting what we need to insert here. And then, oh no, I don't know anything about this triangle, but I do know it's 90 degrees, so it's half base times height. It's half R times R, which again, R times R is R squared again. So here we are. Here we stand. Actually, someone last hour was able to figure out the answer right now. Do you know what the answer is? It is 6. Because really all you have to do is compare just these parts. And I think that's really a way you could do this. You could take this part and compare it to this. All right, so I have to take half of some number, and it's got to equal 18. Half of what equals 18, everybody? What's half of what number equals 18? 36. What squared equals 36? 6, and then that might be the way. But say algebraically that doesn't happen. Say it's not something you can mentally think of. That's how everyone thinks, by the way, mentally. We could take out a GCF in this question. I think I have an idea how I could do this a little differently, but anyway, of R squared. They have an R squared in common. This is a very valid. We were just talking about you guys this morning. GCF factoring gets forgotten all the time. You want to be robotic and have those trinomials and MA at all the time. But when you have two terms, you should look for a GCF, and we do have one. All right, we'll change this to a fourth. So this becomes a 4th pi minus a half, because I pulled the R squared out. Then you can divide by this whole chunk here. I was trying to think, how could I get this? There's certainly something I could do with this fraction to get this to be a non-calculator question. But I'm just going to alleviate that for right now. I'm going to go to my calculator, and I already did it. There it is. I literally used the fraction button. Oh, I'm way up there. I used the fraction button. I think I did that last one. Last hour I got the actual answer. But anyway, and type that in exactly as is. 9 pi minus 18 in the numerator divided by 0.25. If you don't have a calculator that has a fraction button, then you need parenthesis, divide /line, parenthesis. Otherwise, you will not get what you're supposed to get, which is 36. Okay, and then that actually worked out. All right, so good. I got my 36 from my calculator. All right, so the ability to keep this in calculator ready form, then go to the calculator and push the buttons, we get that exact answer. Technically, plus minus, wrong. Plus, oh my gosh. I just hate this pen. But we don't deal with negative radii. It's not a negative number. Algebraically, it's a plus minus, but not there. Okay, then one more thing. AO is 20 millimeters, so we'll snatch that in there, 20 millimeters. All right, I feel pretty comfortable about the way the rest of this way is going to go. You guys are going to be over-prepared for the test on Tuesday. It's great. I love that we're doing that, and that's happening in here. All right, so what would be the plan on this one? Fumble. So I need everything but the segment. So that would be the area of the whole, 3, 2, 1, go, circle, minus the area of the segment. So it's circle minus segment. So that's certainly an easy thing. Circle minus segment. I love area questions like this. Just area of the shaded region. You have to come up with some sort of easy plan there. So area of the circle is simply pi r squared. Minus. Now remember what area segment is. It's sector minus triangle. So I have to put that in brackets because I'm going to need two parts in here. Area of segment, which is sector, which that is, again, 90 over 360. Lucky I got that 90-degree angle again. 20 squared pi minus triangle. That's where our luck comes in. We have a right triangle, so the base and the height is the 20 and the 20 that we have there. Then you close that. And then the other hour I stopped. This one I'll keep going. 20 squared is 400 pi. Then distribute crazy minus 1/4 of 400, which is 100 pi, right? Right. 90 over 360 is 1/4, and I got 20 squared pi again. And then plus. Half of 20 is 10. 10 times 20 is 200. So the answer in exact form is this. And then I can end the video with that. All you'd have to do is go to your calculator and type that to get to the nearest hundredth, right? Okay, so hopefully that made sense. The use of brackets is important here because the area of a segment is two components, and I have to subtract all of it, from the first part, the whole circle. Okay, so I love those questions. It really puts it all together. Hope you feel good about this. I don't think it's all that bad. All right, so we got a plan.